Semiconductor is a material whose conductivity lies between conductor and insulators. There are two types of semiconductor. One is intrinsic semiconductor, another one is extrinsic semiconductor. Intrinsic semiconductor. Semiconductor in pure form is known as intrinsic semiconductor. Example: germanium, silicon. At room temperature, number of electrons equal to number of holes. And this is the intrinsic conductor energy band. And this represents that when the temperature of an intrinsic semiconductor is 0 Kelvin, it behaves like an insulator. When the temperature is increased further, the electrons get excited and move from the valence band to the conduction band. Next, extrinsic semiconductor. Extrinsic semiconductor is a type of semiconductor when we add an impurities to pure semiconductor to increase the charge carriers. Then it becomes an extrinsic semiconductor. In extrinsic semiconductor, without breaking the covalent bonds, we can increase the charge carriers. And this is the comparison of intrinsic semiconductor and extrinsic semiconductor. It is intrinsic semiconductor. It is pure form. Holes and electrons are equal. Fermi level lies in between valence and conduction band. Ratio of majority and minority carriers is unity. In extrinsic semiconductor, it is formed by adding trivalent or pentavalent impurities to a pure semiconductor. Next, number of holes are more in p-type and number of electrons are more in n-type. Fermi level lies near valence band in p-type and near conduction band in n-type. Ratio of majority carriers and minority carriers are equal in extrinsic semiconductor. Next, comparison between p-type and n-type. N-type semiconductor, pentavalent impurities are added, majority carriers are electron, minority carriers are hole. Fermi level is near the conduction band. P-type semiconductor, trivalent impurities are added, majority carriers are holes, minority carriers are electrons. Fermi level valence band is near the valence band. Next, n-type semiconductor. N-type when we add a pentavalent impurities to a pure semiconductor, we get n-type semiconductors. Arsenic atom have 5 valence electron. Fifth electron is superfluous, becomes free electrons and enters into conduction band. Therefore, pentavalent impurity donates 1 electron and becomes positive donor ion. Pentavalent impurity is known as donor. P-type semiconductor, when we add trivalent impurities to pure semiconductors, we get p-type semiconductor. Gallium atom have 3 valence electron and it makes covalent bonds with adjacent 3 electrons of silicon atom. There is deficiency of one covalent bond and creates a hole. Therefore, trivalent impurity accepts 1 electron and becomes negative acceptor ion. Trivalent impurity is known as acceptor. This is p-type semiconductor. In carriers in p-type semiconductor, in addition to this, some of the covalent bonds break due to temperature and electrons holes and pairs generates. Holes are majority carriers and electrons are minority carriers. And this is p-n junction diode, p and n type semiconductor. Here the flow of electrons from n side towards the p side of the junction takes place. Here in p types, as we already studied that in p type semiconductor trivalent impurities are added, and in n type semiconductor pentavalent impurities are added. So n type semiconductor will become donor and p type semiconductor will become acceptor, as you know through this diagram. Next, comparison of semiconductors, intrinsic semiconductors and extrinsic semiconductor. Intrinsic semiconductor, it is a pure form, holes and electrons are equal. Fermi level lies between valence and conduction band. Extrinsic semiconductor, it is formed by adding trivalent or pentavalent impurities to a pure semiconductor. Number of holes are more in p-type and number of electrons are more in n-type. Next, the Fermi level lies near the valence band in p-type and near the conduction band in n-type. And this is the conduction in semiconductor. Conduction is carried out by means of drift process and diffusion process. A drift process, electron move from external circuit and in conduction band of several semiconductor. Holes are moved in valence band of semiconductor. Next, it is diffusion. Moving of electron from higher concentration gradient to lower concentration gradient is known as diffusion. And what happens when we add p-n junction diode? The flow of electron from the n side towards the p side of the junction takes place when there is an increase in the voltage. When there is an increase in the voltage, similarly, the flow of holes from the p side towards the n side of the junction takes place. Flow of p side towards the n side of the junction takes place along with the increase in the voltage. So this is called p-n junction. And these are the some types of semiconductor diodes, transistor, capacitor, etc. Thank you for watching this video.